In order to simplify a function, the expression, using that algebraic rules, it is going to be really hectic. Maybe you might have seen that previously I was trying to do simplification in two methods, and it is very difficult to again trace back and take other path. Once you are done with the shortest, once you got an expression, proving that it is minimal is difficult, first of all, because we got four literal term or four terms expression, and now we don't know whether to say that it is minimal or not, and now we have to see all possible minimal expressions. Therefore, minimization using these formulas and then algebraic methods and applying them some rules, it is all going to be very hectic. So a better convenient method has been introduced, and it is called K-map. So K-map is particularly convenient to represent the function as well as to minimize it. It lends itself so that we could easily visualize the function and then we could easily minimize it. And in GATE exam, they'll give you either 3 variables or 4 variables, and for 3 and 4 variables, K-map is the best way to minimize it. There are other ways also, we shall see it, but K-map is the best one. So let's write some theory. Let's get used to the terminology. What I suggest you is, I'll read out the points. You just keep pausing it and you write the theory. This theory will be useful to help you in solving the questions, definitely. So please write it down, and then later you can revise it easily. So because it entire thing it is going to be a bit confusing from now on. But let me tell you, this is the easiest topic you could think of. In computer science, you could easily solve this and get 4 marks question easily. Okay, let's start with this. K-map. The algebraic procedure of combining various terms and applying them, the rules becomes very tedious as the number of variables increases, which means as the size of the expression becomes very large, then the algebraic method obviously becomes very tedious, right? The map method provides a systematic method for combining the terms and deriving the minimal expression. So the map is actually designed in such a way that it lends itself readily for the simplification. A K-map is a modification of the truth table. So K-map is actually a kind of truth table, because in truth table, what did you see? We find out all the combinations and then we assign the truth value. Similarly here also, in a K-map, for every combination there will be a designated cell. In the designated cell we write the truth value. Therefore K-map is a kind of truth table, even though it looks different, right? It is a truth table in which the arrangement of combinations is particularly convenient for minimization. What is the difference between truth table and this one is, in truth table you cannot directly look at the truth table and keep on combining the terms, but in this K-map you can look at the table, that map, and you could combine the terms and keep on minimizing it. That is the main difference. Truth table and K-map both are almost same. Only difference is, in truth table you cannot apply minimization because it doesn't lend itself, the format there is different, but in K-map it is actually suited for minimization. And now every n variable map consists of 2 power n cells, which means if you have n variables, then how many terms are there? Min terms 2 power n. If you have 3 variables, 8 terms, 4 variables, 16 terms. Every n variable map contains of 2 power n cells representing all possible combinations of variables. For example, a 3 variable map has this big, right, 8 cells, and similarly a 4 variable map has 16 cells, right? So and one more thing, many students, when in the classroom when I teach this, they get confused in one small thing. See this, whenever you are filling the rows, whenever you are putting the numbers about the table, these tables, okay, watch it, I'll just explain you one by one. Now this cell, so whenever you form a table, let us say this is a 3 variable map, which means this is used to simplify any function which is containing only 3 variables like x, y and z, and each cell is going to represent one particular value. For example, this cell is actually representing one min term. What is the min term? See this, it is x, it is y, it is z, which means this column corresponds to x value and y value, and row corresponds to z. It is not a rule that you should always put x and y in the row and z in the column. You could as well put as x here and then y z. It is not an issue. But then when you have fixed upon some convention, try to follow it when you are trying to filling it. Which means when you are trying to take the min terms and write it there, just follow the convention. If you have used x and y, then corresponding element should be made made there, right? And now see this. This particular element, this cell 0, actually corresponds to the min term x prime, y prime, z prime. How? See this, x and y are 0, 0, therefore x prime, y prime, and z is 0, therefore z prime. And if you look at this cell, this particular cell, if you want to know which min term corresponds to this cell, just look at this combination. So x is 1, y is 0, and z is 0. Oh sorry, z is 1. So this cell corresponds to x, y, 1, 0, and z is 1. So what is it? X, y prime, z, right? So that is how you could represent each cell. So all the 8 cells, why are there 8 cells is, if you have a 3 variable functions, the number of minterms present in 3 variables is 8, and each one of them can assume either 1 or 0 independently. Depending on the function, we are going to fill this. And I have written the numbers just for the convenience, but then I suggest you not to by heart them. So one mistake what you might do while constructing this K-map is, here it is 0, 0, 0, 1, then remember it is 1, 0, right? What people try to write is 0, 0, 0, 1, and immediately they will write 1, 0 and then 1, 1. That is wrong. So keep this in mind. It should be 0, 0, 0, 1, 1, 1 and 1, 0. Why is this so? I'll discuss that shortly. Two cells should have only one literal changing. What is that? I'll tell you later in soon. So just remember that 0, 0, 0, 1, 1, 1, 1, 0 has to be used. It is not 0, 0, 0, 1, 1, 0, 1, 1. You don't do that. And next thing is, here also the same thing. It is a 4 variable K-map. If the number of variables are 4, then how many minterms are possible? 2 power 4, which is 16, right? Wx, yz, and all of them can be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, and each cell is representing one minterm. For example, let us say this cell. If you want to know what this cell is representing, just see what wx combinations for that are. The wx combinations are 0, 1, and yz combinations are 1, 1. So w is nothing but 0 is nothing but w prime, and 1 is nothing but x, and yz are nothing but 1 and 1, therefore yz. So w prime x, yz. This is represented by that, right? So the numbers which I am writing in these cells are not of any significance. Don't read them, don't by heart them. For the explanation, I am just giving you that. So don't by heart them. What will be present inside these cells is the truth values for that particular min term. What is the truth value associated? That is what I am going to write it there. Okay, we shall see more about this. I'll explain you. And after seeing this, we shall see some questions, and then we shall go into depth about how to solve all the questions in this. Watch this. The function value associated with a particular combination is entered in the corresponding cell. So once we have the K-map, then go to the corresponding cell which represents that particular min term, and we are going to put that number, put that truth value. For example, look at this one. Let us say, let's not write these function values inside. Let's say it is a 3 variable K-map, right? And assume that the function is like this. The function is sigma 3, 7, which means we have 2 minterms, and these 2 minterms are having value 1, and the other minterms are having value 0. If the function is having 2 minterms, which means in this function only these 2 minterms are given a value of 1 and other are given 0. So what is 3? 3 is, you can write it like this, right? X prime yz. And what is 7? X, yz, right? Therefore only in these 2 cells we are going to put 1, and in the remaining cells we are going to put 0. Now what is x prime yz? X prime yz means 0, 1, 1. So 0, 1, 1 is 0, 1, 1, this one. This is 3, and 7 is x, yz. X, yz means all are 1. So x, y, z, which is nothing but this one, right? So that is how these two are represented. That is the meaning of the first one. The function value associated with a particular combination is entered in a corresponding cell, which means every function is going to have minterms, and the minterms are going to have value 1s, and in that particular cell we are going to put 1. Next one is cycle code is used in the combination as column and row heading. So what is cycle code is, whenever we have a cycle code, it means that we are actually changing, or if you have a cycle code, the property of cycle code is between any two successive numbers there will be only one bit change. For example, see this, if I write 0 0 and from 0 0 if I change to 0 1, if this is next number in the cycle code, only one bit is changing, right? And if I write 1 1, check this, from this to this only one bit is changing. What is the one bit? The first bit. Second bit remains same. And if I change from 1 1 to 1 0 and again one bit is changing, just check this, here from 0 to 1 only one bit is changing, and again from 0 to 1 only one bit is changing, and again from 1 to 0 only one bit is changing, right? That is called a cycle code. Again, at the end I will talk about cycle codes in detail, but for now understand that if I have a cycle code between any two numbers, adjacent numbers, there is only one bit change. Just keep that in mind, right? So what is that they are saying is, cycle code is used in the combination as row and column heading. So look at this row heading, 0 0 0 1 1 0 1 1. If you look at any successive numbers, only one bit changes. That has a practical significance here. I'll talk about it. And even look at the row 0 1, which is nothing but only one bit changing. Now here also you look at it in the four variable map. Look at the column headings, 0 0 0 1, only one bit is changing, and from 0 1 to 1 0 only one bit is changing, and from 1 1 to 1 0 only one bit is changing. The same thing is happening in the row values also, right? So watch this. So what does that mean? We are going to change only a single value either in the row or in the column, right? Whenever we are going from one row to the next row, like that. Because of this, we have some good property there. Because of these codes, what are the codes? Cycle codes. Two cells which have a common side. So what is two cells which have a common side is, look at these two cells, this cell and this cell. These two are having a common side. This is the common side, right? That is what they are talking. Because of these rules, two cells which have a common side correspond to combinations that differ by the value of just a single variable. So what is the meaning of it is, just look at these two. These two cells are having a common side. Because of this property, these two min terms just differ in just one term. So if you write what it is nothing but x prime y z prime. This is x prime y z prime, and if you write this, it is nothing but x y z prime, right? Now these two differ only in one cell. What is this cell? Here these two are same. I mean, what is the variable? Differ in only one variable, right? So y and z prime both are same. Only difference is x and x prime. Got it? And now these two cells play a major role in the simplification process. So because of this difference, we are able to simplify it. Why is this K-map really suitable for simplification procedure is because we are having cycle codes representing the headings, and because of that, two cells which are adjacent are going to have only one variable difference, because of which we can apply the simplification rule like this. See this. Now when we have only one variable changing like this, we can pull out the common variable side. So what is that we can pull out? Y z prime, we can pull it out. Then we can combine happily x prime and x. Then what is it? It is nothing but 1. So simplification has happened only because of this rule. What is the rule? The headings are cycle codes, and now they are differing. Two cells which are adjacent are just differing in one variable, right? So these two cells play a major role in simplification procedure because they can be combined by means of the rules this one. So when there are two min terms which are differing by only one variable, and that variable can be eliminated, isn't it? Therefore by combining two cells, I can eliminate one variable. What if I combine four cells? In four cells, how many will be differing is 2. If I combine four cells, I can eliminate 2. Okay, we shall see it. Don't worry, we shall go step by step. So what is this entire procedure is? Now I am able to draw the something called as K-map, and K-map has an inherent character that the row headings or column headings are going to be cyclic codes, because of which if there are two cells which are adjacent to each other, which are having a common side, then definitely we can combine these two cells and we can minimize the expression. How? By applying the rule which we have just seen, right?